Yeah. So, hello guys, welcome to iitiansgateclasses. So, in this session, we are discussing mock exam 2, All India mock exam 2, which is uh, IGC mock 7 solution. And in this session, we'll be discussing for aircraft structures and mechanical vibration part questions. Okay, so total 3 questions and which are for 6 marks. So let's see this question. Yeah. So what this question says, a thin tubular shaft of circular cross section with inside diameter 100 mm is subjected to a torque of 5000 Newton meter. If the allowable shear stress is 42 megapascal, determine the required wall thickness T by using the approximate theory for a thin wall tube in mm. And they asked answer in 2 decimal places. So guys, what is given in this questions, T allowable is given, which is how much? 42 megapascal. And we know what is the approximate theory for thin wall tube. It is known as Brad-Weather theory. Brad-Weather theory, right? And according to Brad-Weather theory, we know the applied torque T is given by 2AQ, where Q is what? Q is known as shear flow, and Q is nothing but 2A into tau into T. Okay, tau into T. What is A? Here, A is cross-sectional area. Cross-sectional area. So, guys, now from here, what will be your tau, the applied torque? So applied torque can be given by what? Applied shear stress, okay, or maximum shear stress, you can say, can be given by what? Torque upon 2 into cross sectional area into thickness. Now guys, in this problem, what is given? They given inner diameter, okay, they given inner diameter, and they gave, and thickness is unknown. Okay, so this inner diameter is given as 100 and thickness is what? T. Now guys, in approximate theory, instead of inner diameter, what we use? We use mean diameter. So in this case, what will be mean radius? We use mean diameter, okay, not inner diameter, or we use in calculation mean radius. So mean radius will be what? R internal plus T by 2. So R internal is how much here? 50, and thickness T by 2. Now what is the area? Cross sectional area? It will be equal to what? Pi R mean square. So substitute here. Now guys, T. So they have given T allowable, and for that T allowable, tau allowable they have given, and for this tau allowable we need to find this thickness T. So what is tau allowable? It is 42 megapascal. So now we will keep all the unit in Newton per mm. So 42 megapascal is nothing but 42 Newton per mm square. Now torque is given 5000 Newton mm. So we'll convert to Newton meter. So it is Newton mm. Now 2. What is the area? It is pi. Now r square. So r mean square is what? 50 plus t by 2 whole square into t. Now what is unknown? Thickness. Remaining all is known. So what we see here, it is 100 plus t whole square, okay, into t is equal to what? 5000 into 10 to the power 3 into 4 divide by 84 into pi. Okay, guys, please check, is this correct? Now from here, if you solve this is coming as 75788. Okay. Everyone, is it clear? Now guys, you can see this side. It is not square term. If you expand it, it will be a cubic term. And you guys cannot solve this in your virtual calculator, right? You guys can't solve. Saurav, yes or no? So what is the trick to solve this question? If this question is asked in your exam, what is the trick? Anybody can tell? Vivek, Irfan, Vishal, Devika. So what is that trick? So I'll tell you how to solve this question because we don't know what can be the value of t. So I will tell you one way, guys. Here they given inner diameter as 100. So usually we can neglect t cube term, we can neglect, right? Higher order this is one way. See, this is one way. What you can do, the higher order term, if you neglect, so it will be t cube t square. Okay. Not t square term will not be small. T cube term will be small. Okay. T cube term will be small. So what you get? You will get t cube plus 200 t square plus 10,000 t equal to 75788. Now we already know in the approximate theory, right? We can neglect t cube term, right? So from here, guys, find out the value of t. Find out the value of t, guys, quickly. Can anybody find? This is one way. The another way I will tell you, okay, that is even easier, okay, that is even easier. What is the other way? See, this is thin tube, right? Now inner diameter they given 100. So what can be approximate thickness in case of thin walled structure? What can be the thickness range? It can be 5 plus minus mm, right? Yes or no? In thin walled structure, usually what is the thickness? Usually it is 5 plus minus, right? It can be 3 mm, 2.5 mm, 5 mm, up to 10 mm, right? Yes or no, guys? If T is 5 mm, so what will be R mean? R mean will be 52.5. Am I correct? So let's consider from here T equal to 5. So from here, guys, if you consider R minimum equal to 52.5, what T you will get? So T will be now what? Small t, which is what? Thickness. Thickness will be what? Tau allowable into 2 into pi r square. Okay, r mean square. Now guys, from here Now from here, everything is known. So it is what? 5000 into 10 to the power 6 into 42 into 2 into pi into 52.5 square. Okay. Now guys, from here my t is coming approximately 6.86. Okay. Now guys, what you can do, you can substitute this 6.86 in this equation. Okay, or in this, and try to check. If you substitute 6.86, if you substitute 6.86, you will be getting a value greater than this. That means the value should be lesser than 6. So you can check then. First guys, check for 6.86, then check for 6.8, and then check for 6.7. So you will get for 6.7, and you guys can check for 6.6 also. So what we will see, for 6.7 the value will be slightly higher, and for 6.6 it will be slightly lesser. So your answer will be between 6.7 and 6.6. So you can say your answer is 6.65. Okay. So 6.65 is your answer. So you guys can start, since it's an approximation, right? So instead of 6.86, better we can start with 6.8. Then we'll come to know when we substitute 6.68, your left hand side will be greater than right hand side. Then for 6.7 also, it is your left hand side is greater than right hand side. And for 6.6, your right hand side is greater than left hand side. So your answer is between 6.7 and 6.6. Is it clear? Everyone, is it clear? Yes or no? And you can see the range is also given between 6.5 to 6.8. Okay, there is no other way to solve this question if it comes. Okay, so but concept, is it clear, right? It is simple. T equal to 2aq, and we know your applied shear stress is what? Torque upon 2a into t, and where a is what? Cross sectional area, and cross sectional area is given by what? Pi into r mean square. Everyone? Okay. Now guys, can anybody tell what is the answer from this? Anybody could solve this? Because I didn't keep solution for this. While solving, I thought that way. Anybody can tell the answer from this? Let me see. So it will be minus 378.9 equal to 0. It is t square plus it is 10,000 divided by 200. So it is 50. Now, can anyone tell quickly the answer from this? I just want to know. Vishal, this t square plus 50t minus 378.9 equal to 0. Can you solve this cubic equation, guys? Right? So it is coming 6.68, right? Perfect, right? So guys, this is how we need to solve this question. Everybody clear? Because in thin walled approximation, everybody know, right? When we find cross sectional property, we neglect higher order term of thickness. T cube term we are neglecting, right? So if you neglect here, you are getting, right, 6.6850. Clear? So even this is the easiest method, right? This is the simplest, right? Even directly we are getting answer, right? Which is very close to your, which is within your range without any trial and error. Okay, and here also you can see your answer is in between 6.7 to 6.6, which is 6.65 we consider. So good, guys. Let's see next question, what it says. Yeah. So what it says, the partial differential equation for a torsional vibration of a shaft of length L, torsional rigidity Gj, and mass polar moment of inertia I, where theta is the angle of twist. If the shaft is fixed at x equal to 0 and free at x equal to L, the boundary conditions are. So guys, in case of vibration of shaft, we know the what are the boundary condition at fixed end. At fixed end, guys, what we know, the angle of twist theta is 0, but dou theta by dou x is non-zero. So here, guys, fixing is what, at x equal to 0. So you will see at x equal to 0 theta is 0, but at free end your rate of change of slope will be non-zero. So this is at what, x equal to L. So what is the correct answer? Look into the options. So we know theta, which is at x equal to 0, is 0, and dou theta by dou x at x equal to L is also 0. So D is the correct answer. What is the correct answer, guys? You guys can see here in option A is the correct answer. There are four options given. Okay, is it clear to everyone? Let's move to next question, guys. What it says, consider a prismatic straight beam of length L equal to pi meter. Actually, this question is from strength of material, but listed here we can solve. It's an easy question. Pinned at two ends, the beam has a square cross section of side A equal to 6 mm. The Young's modulus E equal to 200 gigapascal. The coefficient of thermal expansion alpha is given. the maximum temperature rise required to cause Euler buckling of the beam. So guys, in this case, it's a prismatic beam and it is a pinned at both the ends. Pin means simply support. At both the ends, it's a simply support. Okay. So guys, we know in case of simply support column, what is your P critical? P critical is given by pi square EI by L square. Now, what is sigma critical? Your sigma critical will be what? P critical by A. And we know thermal stresses induced due to temperature is given by what? Alpha E delta T. Now, what is this sigma critical in this case? It is what? Pi square EI by A into L square. Now, guys, at failure, at buckling, your sigma critical should be equal to what? Sigma thermal. So, from here, if you write alpha E delta T equal to pi square EI EI upon A L square. So E got cancelled. What is unknown? Delta T. Now guys, what is length? Pi square. What is I? The I is A power 4 upon 12. What is the area? A square. What is the length? Pi square. Then alpha. So from here guys, we have to convert all the unit to Newton mm. Okay, so A is in what? Mm. So we need to convert to Newton meter. Okay, or you can say SI unit. So substitute here because length is in meter. So when you convert here, A square will get cancelled. So what we get? Pi square into 6 square into 10 to the power minus 6 upon 12 pi square. What is alpha? 3 into 10 to the power minus 6. So you can see this got cancelled. 36, 12 into 3, 36. Pi square got cancelled. So temperature rise required is what? 1 Kelvin. So 1 Kelvin is your answer. Okay. If temperature increases to 1 Kelvin, your column will buckle. So is it clear, everyone? Yes or no? So these three questions were there. Okay. Basically two questions. So the good question is what? The first question, where you have to use and same time you need to approximate. So you will get answer. Yeah. So that's all from session. Thank you guys for watching this session, and you guys can follow us on different social media platform for further support from IGC. Okay, Irfan, you have any question, any doubt? Vivek, do you have any doubt apart from these questions? Okay, then thank you. See you in next meeting.